Hi guys, we're going to practice finding the area of composite figures for lesson 9.3. It's my first time ever making a video like this, so if I stop, forgive me. Alright, so our goal with these composite figures is to figure out how we can use what we already know about the area of 3D figures or the area of flat figures and put them together to create the area of a composite figure, which is just a bunch of figures put together. So if we're looking at the figure here on the right, the first question is asking us, describe one way you can find the area of this garden. This is a composite figure because it's made up of many smaller figures. One way we can find the area of this figure is to divide it into rectangles. For example, here and here, and to also divide it into a triangle. So we're left with two rectangles and one triangle. So we can write that we can divide the figure into two rectangles and one triangle. And now I can more easily find the area of the garden. Okay? If I want to find the area of this figure, I have 2 times 3, which is 6. Here I have 4 times 8, which is 32. And the area of a triangle is 1/2 the base times the height. So our height is 2, and our base is 1, 2, 3, 4, 5, 6, 7, 8. So 2 times 8 is 16, times half is 8. So if I added that together, I would have 32 plus 8, which is 40, plus 6, 46 square meters. Now, we can compare with other students, but unfortunately, we're not together, so let's skip that one. How does the area you found compare with the area others found, or different methods? All in all, we should all still be able to get the same answers. Some of us might have divided it into rectangles in a different location. Okay, so if I look down here, I could divide it in the way that I did up above. Or I could have gone on and divided it again into a triangle and a rectangle this way and a rectangle this way. And at the end of the day, I should still be able to receive the same answer. Okay, so that's working with composite figures as maybe like a 101 kind of level, just the easiest way possible. Now, moving forward, these are some really important equations that you guys must be able to memorize or work with over and over again. It's just the different areas of the shapes that you'll be working with. So a triangle, 1/2 base times height. A square would be side times side, or side squared. For a rectangle, the length times the width. A parallelogram, similar to a rectangle, base times height. And for a trapezoid, probably the harder one, would be our 2 bases added together times the height times half, right? Or divided by 2. So now we're going to move forward into actually practicing with, sorry, that was paper, actually practicing with the composite areas of figures. Here I have a randomly shaped figure, right? Not something I would ever really draw out or work with, but in composite area, we need to understand how we can separate this to help ourselves. So it says separate the figure into smaller familiar figures. For example, it already found a parallelogram for us. That would be this top part here. And it already found a trapezoid for us, this bottom part here. And now, using the equations we know for parallelogram and for a trapezoid, we're able to actually find the area of this whole composite figure. For example, if I found the area of this parallelogram, I would look at it as 3 centimeters by 10 centimeters, just like I have over here, with a height of 1.5 centimeters, just like is given to me there. So for the area of a parallelogram, I multiply the base times the height. In this case, my base is 10, and my height is not 3, Okay, that is more considered width. It would be 1.5. So if I follow along, the area of my parallelogram is 15. But not just 15, don't forget, it's centimeters squared. Okay, I need to keep that in mind as I move over to the trapezoid. Here I have the equation 1/2 times the height times the sum of base 1 plus base 2. So I completely ignore the top part, which is the parallelogram, and I'm only looking at the bottom. So I need to really make sure I focus in on the numbers that are labeling only that bottom trapezoid. Okay, so here I have 4 centimeters, a base of 7 centimeters, another 2 centimeters, my height, and then I have to remember that this connecting base, okay, is going to be 10 centimeters because that was the height or the base of my parallelogram. Okay, so I'm first going to go ahead and add my 2 bases, 7 plus 10, right? Order of operations would tell me do the parentheses first, so I have 17. My bases are the top and the bottom of my figure, multiplied by my height, which again here is 1.5, all multiplied by half or divided by 2. Okay, so I could have started with multiplying the height times the sum of my 2 bases, which was 17. So I would do 1.5 times 17 and get 25.5 for these two. And all of that I could have divided by 2 to get 12.75 centimeters squared. That's a lot of work, but I'm still not done because the goal is to get to the area of this composite figure, which means I have to add my parallelogram area with my trapezoid area to get a total of 27.75 centimeters squared. I hope that made sense because we're going to put it into some practice right now. Okay, let's go ahead and work on number 2 for practice. Okay, with number 2, we can tell that there's a couple of shapes in this composite figure, and it actually already broke it up for us to make it easier. Okay, so here it separated it into 2 triangles and 1 rectangle. I can go ahead and find the area of this rectangle, and I'll have my calculator handy, right, because you guys took one home and you should have one available, and in this unit you definitely need it. I need to find the length, and then I need to find the width of this rectangle, right? So I have 4, and then my length is not just 8 units or 8 feet because I can't forget that this rectangle extends all the way out. So I need to add this 3 feet plus this 8 feet to get a total length of 11. So for my rectangle, I would do, and I'll label it R, the area of my rectangle is 11 times 4, which is 44. Okay, and I'm not done because now I need to go back to the triangles. And I'll do them separately because it looks like one triangle, and we have to be careful with this all the time that we don't confuse or just assume. One triangle has a base of 3 and one triangle has a base of 2. So for a triangle, our area is 1/2 times the base times the height. So if my base is 2 feet and my height is 3 feet, that is 2 times 3, which is 6, times half is 3. So my first triangle is 3. And then my second triangle, I have a base of 3 feet with a height of 3, which is 3 times 3, 9. Divided by 2 or times half is 4.5. In order to finish, I need to add all of those together to find the area of my composite figure. So I have 44 plus 3 plus 4.5 is going to give me an area of 51.5, But I'm not done because I'm forgetting what? I'm forgetting my units, and for area, it's going to be units squared, so feet squared. All right, let's go ahead now and move on. Okay, I'm skipping number 3 because we're gonna see something similar to number 3 as we move forward. And all you would really have to do for that one is take on what you did with the last lesson, which is find the area of a circle, right? And in this case, you would find the area of this square, 10 times 10. I guess now that I started it, we can do it. Why not? 10 times 10 for the square is going to be an area of 100 meters. And now in order to go ahead and find the area of our circle, right, we have area equals pi times radius squared. And as you should notice, I hope, is that we don't have a full circle. We have a semicircle. So whatever I do, in the end, I'm going to cut in half because I cannot pretend that this is a whole circle. So let's find our radius first to fill in the blanks. 1, 2, 3, 4, 5. And don't forget, radius is only half the distance. So I have pi times 5 squared. So in my calculator, I will put in 3.14 times radius squared, 5 squared, which is 25. And that gives me 78.5 units. But that would be a whole circle. I have a semicircle. So hopefully you're saying to yourself that I need to divide that by 2. So I'm going to divide 78.5 by 2 to get 39.25. Now I'm actually able to put these together. Okay, so I should be able to add 100 for the square plus 39.25 for the semicircle and get 139.25 meters squared. I'm really hoping that made sense for all of you. Okay, now let's move on. Using area to solve problems. And I promise, I'm gonna get better at this video thing. Okay, it says a banquet room is being carpeted. A floor plan of the room is shown at the right. Each unit represents 1 yard. Okay, so each of these smaller units. The carpet costs $23.50 per square yard. How much will it cost to carpet the whole room? So, again, I'm working with a composite figure. I need to break that composite figure like it did for me into manageable pieces. In this case, it made a rectangle, it gave me a parallelogram, and it gave me a triangle. And now I'm able to use what I know about parallelograms, rectangles, and triangles to actually solve this problem. The area of a parallelogram is base times height. In this case, the base is 1, 2, 3, 4 units, and the height is 1, 2 units. So 4 times 2 is 8 yards. I'll move on to my rectangle. Length times width. My length is 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4. 6 times 4, 24. My triangle, little smaller but still manageable, I have a base of 1 and a height of 2. So 1 times 2 is 2. Times half or divided by 2 is going to give me 1 yard. Now, in order to finish that up, sorry, my kitty is here. I need to get her off. In order to finish that off, I need to add all of the areas of my figures, 8 plus 24 plus 1, to find out all the yards I'm working with. And I'm working with 33 square yards. Quickly tell yourself why I need to figure out how many yards are in this figure. Okay, if you're saying it's because we need to find out the cost per yard, you're correct. So if each square yard, each one of these 33 square yards is $23.50, I need to multiply 33 by $23.50. And when I do that, I get $775.50. That means the cost to carpet this entire banquet room is $775.50. Okay, this is real stuff, guys. When you ask me in math class all the time, will we ever use this in real life? Definitely. Think about how much your parents have done in your house, what they've had to remodel. Think about you guys becoming interior designers one day, or architects, or anything. You're going to need to know this just for your own self. So let's put it into practice. Last problem, and you're on your own. Okay. It says, a window is being replaced with tinted glass. The plan at the right shows the design of the window. Each unit length represents 1 foot. That makes sense. The glass costs $28 per square foot. How much will it cost to replace the glass? So just like the last problem, I need to know how many square feet there are because I need to know the total cost. And it's asking me to use 3.14 for pi, which is exactly what you guys do all the time. So quickly go ahead and tell yourself, what are the two figures we're working with in this composite figure? If you said a rectangle, and if you said a semicircle, you're correct, right? Even if you said a full circle, you're correct. Because I could technically split this into this rectangle. And because these two semicircles are congruent and identical with the same diameters, right? And the same height, my cat is gonna jump up here. You could put those two semicircles together to find the area of the whole circle. So let's start with the rectangle. The base of the rectangle is 1, 2, 3, 4, 5 by a width of 1, 2, 3, 4. So for a rectangle, 5 times 4 equals 20. So the area of the rectangle is 20. Plus, how do we find the area of a circle again? What's that equation you guys are supposed to use? Area equals pi times radius squared. Okay? So if I find my radius, not my diameter, my radius will be half. Hello? 1 second. My kitty cat. If I find my radius, that's the reality of being home and teaching. My radius is 2 units. So 2 units squared is 4. So I have pi times 4. Okay. And I'm going to use 3.14 for pi. So in my calculator, I'll do 3.14 times 4 to get 3.14 times 4, 56. Now, that's the area of the whole circle. Some of you see this as a semicircle. If you were to divide this by 2 and use it twice, it would still bring you back to 12.56 because these two sides make a full circle. So don't give yourself the extra work. Look ahead and plan it out. So I'm going to add 20 plus 12.56, and I should get an entire combined area for my composite figure of 32.56 feet squared. But I'm not done, hopefully you're saying, because the goal wasn't just to find the area, the goal was to say what is the cost of the entire replacement of the glass. So in order to find that, I hope you're saying to yourself that you're going to multiply 32.56 as your area times 28. And you should get a cost of 32.56 times 28 to get you $911.68. Did you get that? I hope so, because I'm not there with you right now, so hopefully you're all saying yes, okay? Now, for homework tonight, you guys are just going to work on the odds again. So 5, 7, 9. Our goal behind doing this is because we want to make sure that you guys are being able to check your answers in the back of the book too. Now, if you want to go ahead and do number 6, 8, and 10, that is completely fine. I'll go ahead and post a picture of all of those answers for you, okay? So make sure you look in your Google Docs assignment under our Math Classroom or Math Excel Classroom, and you'll see this page of homework, independent practice, with the answer key, okay? So you're only doing the odds on page 281. All right, guys, have a good day. This is my cat. Bye-bye.